world first, researchers at the Royal Melbourne Hospital and the University of Melbourne have implanted a tiny device into a man's head that is able to read his brain signals and allow him to wirelessly make commands on a computer. Joining us is Professor Bruce Campbell from the Royal Melbourne Hospital. Bruce, this is incredible research to help paralysed patients. What does the device look like and where is it implanted?
A stent is a little wire mesh, if you like, and it expands inside a blood vessel inside the brain. So the trick is to get it up there, and that's the cleverness of the interventionist, to feed a small tube from usually the leg up into the brain vein and deposit this little net in the vein in the brain.
Gee, that's just incredible. How long did it take to develop?
It's been a process over many years, at least 5 and probably longer, I think.
And whereabouts does it sit in the brain?
The sagittal sinus is the main vein draining the brain, and it sits essentially just up here, if you can see that, under the skull.
And tell me about the trial that you had with Phil.
So Phil is second patient in the world to have one of these devices implanted, and he has motor neuron disease and has therefore lost function in his arms. And one of the things he wanted to be able to do was to control a computer. And so with the Stentrode in place, he's able to use eye tracking software, which is not related to the Stentrode, to guide the cursor on the screen, and then use the Stentrode brain control switch, if you like, to click and drag. So he can click on letters, he can zoom in on a certain part of the screen and select what he wants to select. And he's been able to write emails and send messages and do his internet banking and things like that using just the power of his thought, which is amazing.
So no movement at all, it's just, as you said, the power of his thought. It's amazing.
Yeah, so the electronics is picking up brain signals of him thinking about moving his ankle and translating that recognition of that signal into a mouse click.
Could this also help quadriplegics?
Absolutely. I mean, this is really just the first proof of principle that it's a safe thing to do and that you can record brainwaves in humans, which has never been done before in this particular way. So at the moment, it's being used to transduce a mouse click, but there are many potential uses for this, not just controlling a computer, controlling external devices, and then other applications completely different to paralysis. So potentially either recording brainwaves or stimulating using the electrodes in the brain.
Has the team tried anything like this before?
Look, this is an entirely novel procedure. So Nick Opie, who's the engineer, developed this device from scratch, built the original ones by hand, and it's really a very novel process.
Phil is a very brave man. Do you have any other people that you're going to try this on?
Yeah, the pilot phase is 5 patients. So we have a program in place to get data from a number of patients to make sure that it is as safe as we believe it is, and to really get an idea of what the capacity of this device is.
And can it help other patients with other neurological conditions like, say, Parkinson's disease?
Parkinson's disease is not so much a disease of paralysis as such. People have difficulty controlling their movements and so on, but there are other applications of this kind of device in the brain that may be relevant to Parkinson's. People have a treatment called deep brain stimulation, which at the moment requires brain surgery to implant electrodes, and conceivably this same approach of putting the electrodes in via a blood vessel could be relevant in future, but that's not on the cards at the moment.